Hello, students of science. Let's talk about the types of chemical reactions: synthesis, decomposition, single displacement, double displacement, and combustion. First one, synthesis reaction. Like it sounds, something is being built together, or composition reaction. In a synthesis reaction, two or more substances are going to combine to form a new compound. Think of it this way: A plus X is going to make the compound AX. Here we have the blue circle plus the red circle is going to make a blue circle and a red circle. This is a synthesis reaction. I'm combining them. An example of this would be when you burn hydrogen and oxygen together. Hydrogen plus oxygen is going to combine, synthesize, into making water. So that's the synthesis. Hydrogen plus oxygen makes a compound with both of those together. So our synthesis reaction right here, we can see we have this blue molecule and the orange one coming together. Here I have the pink one and three orange ones coming together. So this is synthesis. It's A plus B making AB, or in this case, A plus B plus C making ABC. But either way, we are looking at all these combining. Next up, let's look at a decomposition reaction, essentially the exact opposite of a synthesis reaction. In a decomposition reaction, a single substance is going to break down to form two or more simpler substances. So AX is going to break down to be A plus X. So the exact opposite of our synthesis reaction. So here I have the blue-red one that we saw in the last one is going to make a blue plus red. They are now separate. Example of this would be ammonium hydroxide is going to break down to form water and ammonia. So I start with one large compound here. It breaks down, it decomposes to make water and ammonia. So here I have the compound AB. This is going to decompose to form these separate ones here. In this example here, ammonium dichromate is going to break down to form nitrogen plus water plus chromium 3 oxide. Another example here, I have AB is going to break down to form A plus B, so those separate ones there. Here I have another one. One large compound is going to break down to form multiple smaller compounds. So that is a decomposition reaction. Next up, single displacement reaction. Essentially, in this case, we're going to be switching something. In a single displacement or replacement reaction, one element is going to replace a similar element in a compound. So here I have A plus BX is going to make AX plus B. So you can see that A and B switched. A took B's place. So here I have blue-red plus green is going to make red-green plus blue. So in this case right here, the blue and the green have switched places. Example of this, magnesium plus copper sulfate is going to make copper plus magnesium sulfate. So the copper and the magnesium switched places in a replacement reaction or single displacement reaction. Some examples. I have A plus BC is going to make B plus AC. So here the magnesium is taking the silver's place right here. So it switches it out. Nothing happens here. It's just the magnesium replaces the silver in that compound. Another similar one right here, this is going to be a single displacement. I'm essentially going to be replacing something on here. I am now taking that hydrogen off of this one molecule and putting it onto the other. Here I have another one, this yellow on the outside of this molecule right here is going to switch places eventually, and it's now going to leave. So the yellow one got replaced with the green one in our molecule there in a single displacement or replacement reaction. Let's talk about double displacement. In a double displacement, the ions of two compounds are going to exchange places. So they're going to form two new compounds. So AX plus BY is going to make AY plus BX. A and B have completely switched places. They both arrived with one partner. They're both leaving with a different partner here. So here I have the red-blue and the green-purple, and they are going to switch. The blue and the purple are going to completely switch which ones they came from. Red was with blue, now it's with purple. Green was with purple, now it's with blue. So the red and the purple have switched who they came with. An example of this, silver nitrate plus sodium chloride is going to make silver chloride plus sodium nitrate. So the silver and the sodium have completely switched places, who they came with and who they are leaving with. When I'm neutralizing an acid or a base, that's going to be a double displacement reaction. Here I have hydrochloric acid is going to be reacting with sodium hydroxide, and those are going to be switching it off. So I'm going to leave with sodium chloride and water. Both of them are switching who they came with and leaving that way in a neutralization. Here's another one, copper sulfate and sodium carbonate. You can see the sodium is going to switch over and the copper is going to switch over. So this is a double displacement. In a single displacement, only one would move, but in a double displacement, they are both switching who they came with and who they are leaving for. Finally, we have combustion reaction. In combustion, a substance is going to combine with oxygen and it's going to release a large amount of energy. It's going to be burning it. So here I have a compound plus oxygen is going to break down and you're going to get these compounds each with their own oxygen there. Example of this, C3H8, more commonly known as propane, what you might see in like a propane torch or a propane gas grill. Propane is going to burn with oxygen, release a lot of energy, and it's going to create carbon dioxide and water. So here I have this combustion reaction. This is propane. I can see C3H8 is going to recombine with these oxygens there to make water and CO2. All right, so let's do a quiz. We'll kind of go over these 10 here. What I'd recommend is you pause the video right now and go through these 10 on your own. Try to figure out what they are. So pause the video right now and play it when you're done to check your answers. And we're back. Let's go through these. First one here, magnesium plus hydrochloric acid is going to make hydrogen gas and magnesium chloride. Survey says that is a single displacement reaction because essentially the magnesium is going to be kicking out the hydrogen there and I'm going to be forming magnesium chloride. So single displacement, magnesium kicks out hydrogen. Next one, C3H8 plus 5O2 is going to make 3CO2 plus 4H2O. That's a combustion reaction. Next one, rubidium plus sulfur is going to make rubidium sulfide. That's a synthesis reaction. So I start with two things that are simple and I'm going to end with something much more complex. Next up, aluminum plus lead nitrate is going to make lead plus aluminum nitrate. This one right here is going to be a single displacement reaction because once again the aluminum is kicking out the lead and they're going to leave with different partners. Lead came in with a partner and it's going to leave by itself. Next up, hydrogen plus oxygen, that's going to be a combustion reaction. Going to be producing water vapor. Dead giveaway, burning with oxygen, releasing a lot of energy. Iron sulfide plus hydrochloric acid is going to make hydrogen sulfide and iron chloride. That one is going to be a double displacement. Iron arrived with sulfur and is going to be leaving with chlorine. Double displacement, and the sulfur arrived with the iron and is going to be leaving with the hydrogen. So both of them switched their partners. Double displacement reaction. Next one, potassium chlorate is going to make potassium chloride and oxygen. That's going to be a decomposition reaction. I start with one complicated thing and it's going to break down and form two smaller, simpler molecules. So it's decomposing, the opposite of a synthesis. Next one here, calcium carbonate is going to break down to form calcium oxide and CO2. That's another decomposition reaction. I have one complex molecule that I start with and two simpler ones that I end with. Next up, magnesium and oxygen is going to form magnesium oxide. That's a synthesis reaction. Going to combine together to form a more complicated molecule. So that is synthesis. Next up, hydrochloric acid plus sodium hydroxide. Both of those not things that you want to drink, but if you put them together, they're going to form sodium chloride and water, also known as salt water. If you combine these in the right amount, hydrochloric acid and sodium hydroxide, which is in Drano, you can make salt water. But in this case right here, we're looking at a double displacement reaction. The hydrogen and the sodium are going to switch who they came with. Sodium came with hydroxide, gonna leave with chlorine. Hydrogen came with chlorine, gonna leave with the hydroxide forming water right there. So there we have it, our 5 types of reactions.